Hello my dear students, good afternoon. Welcome back for the next lecture. Today's topic is derivation of Gauss's theorem. In the previous lecture I have told you about the Gauss's theorem. What was the Gauss's theorem? It was simply flux equals to electric flux equals to the surface integral of electric field over an enclosed surface equals to 1 upon epsilon naught times the total charge enclosed inside S. वैक्यूम में है तो एप्सिलॉन नॉट आ जाएगा, और कोई मीडियम है इसी के नीचे क्या लिख देंगे? एप्सिलॉन आर लिख देंगे. Let us consider in vacuum. The derivation of Gauss's theorem. Let us consider closed surface S, spherical or irregular. See, we have two cases now. कोई भी surface हो सकता है, spherical भी हो सकता है, irregular भी हो सकता है, which encloses a single point charge Q. तो पहले मैं irregular लेके कर दूं. For example, this is an irregular surface. कैसे भी ले सकते हैं, और irregular ले सकते हैं. Like this. It encloses a charge Q here. And this is an irregular surface. Let's draw it. So let's take a point, any point P on this surface. Let us consider the point P on this surface be at, say, here. This is the point P. At the surface, at a distance R. So what is the electric field intensity at point P because of this charge Q? We know the electric field intensity at this point is given by Q upon 4 pi epsilon naught R square. And this is the magnitude. And if I want to give the direction to E vector, और यहाँ पे हमें क्या लिखना पड़ेगा? R cap. तो इस point पे इस charge के कारण electric field intensity क्या होगी? This much. And what's the direction? This is the direction of E vector, or you can say it is along R cap. ये मैंने previous lectures में बताया. If it is positive charge, तो बाहर की साइड होगा. If it is negative, तो अंदर की साइड होगा. So flux remains same. It is either it is positive or negative. So we have to take a magnitude of this charge. Say this Q, and it is positive. Equation number 1. So let us consider this is surface. Let us consider some surface element here. So this is surface element ds. ds आपको ये नजर आ रहा है, इसका कुछ पार्ट उस साइड है, बैक साइड में. This is ds. Since it is an irregular surface, इसका n cap कहाँ पे है? I think this is n cap. See, this is n cap. And what is the angle between n cap and E? It is theta. Since it is an irregular surface, तो theta may or may not be equals to 0. तो हम पहले irregular surface के लिए करें. This is n cap, this is E, this is R cap. So let's find the flux. What is flux? Flux equals to surface integral of electric field E dot n cap ds. So surface integral closed. See, surface is closed. This closed surface integral mod of E. What is n cap? Mod of n cap 1. What is ds? ds cos theta. E vector dot n cap ds. Otherwise आप इसको इस सब resolve कर सकते हैं. You can take it. This is the definition of flux. E dot n cap ds. हाँ, कुछ बच्चे सोच रहे हो कि मैंने यहाँ पे ऐसा नहीं लिखा. ऐसा भी लिख सकते हैं, no problem. Sometimes I write like this, sometimes like this. तो चलो ऐसे कर देते हैं. Surface integral. What is mod of E? This is. It is Q 4 pi epsilon naught R square. Mod of R cap is 1. N cap is 1. ds is ds cos theta. See what we have done? We have put the value of mod of E, Q upon 4 pi epsilon naught R square. What is R cap? You can take 1. mod of r cap it is 1, mod of n cap it is 1, ds cos theta. Take the constants outside. What is the constant? Q is the constant. इसके अंदर constant Q है. 4 pi is constant. Epsilon naught is constant. But which is the variable? ds cos theta upon r square. This is surface integral. This is the variable. Mod of r, mod of n, both are 1. And this is q upon 4 pi epsilon naught. Now, question is that what is this thing is called? What is this thing is called? This is a solid angle. What is this? Solid angle, and this simply is called d omega. What is d omega? It is ds cos theta upon r square. It is a solid angle and its value is 4 pi. अगर आप इसे इंटीग्रेट कर दें तो this gives rise to 4 pi steradians. What it gives? 4 pi steradians. So what's our answer? It's q upon 4 pi epsilon naught into 4 pi. 4 pi cancels. So we got q upon epsilon naught. So see, this is flux. Electric flux equals to surface integral E dot n cap ds. हमने mod of E डाला, mod of n cap ds डाला, cos theta डाला. What's the value of cos theta? What is the value of mod of E? Q upon 4 pi epsilon naught r square. R cap it is 1, n cap it is 1, ds cos theta. Take the constant outside q upon 4 pi epsilon naught, ds cos theta by r square. Now, this is the question from where this comes. So this is a solid angle. I have not taken this topic, but I will take someday. Solid angle. So what is solid angle? It's a three-dimensional angle. We have a plane angle which is in radians. This is a solid angle. So solid angle को आप integrate करेंगे तो we get in omega. So this is solid angle, and the value of the solid angle is always 4 pi. In this case, if it is a spherical, क्योंकि at least we can cut a sphere. कम से कम इसमें एक sphere कट कर सकते हैं, और sphere का solid angle कितना होता है? 4 pi steradians होता है. तो 4 pi आ गया, 4 pi cancels. This is q upon epsilon naught. This is for an irregular surface. See, for an irregular surface. लेकिन अगर irregular surface ना हो, spherical surface से करना हो, then it becomes very simple. Then it becomes very simple. Let's take a spherical surface. Now see, let us consider a charge Q at the center of a spherical surface. Say this is a spherical surface. And say this is a point P at a distance R. What is the electric field? Same is the electric field. What is the direction of electric field? It is same along R cap. Now we have to take surface element ds. This is the surface element ds. इसका दूसरा पार्ट है उस साइड है, और इस केस में सिंस स्फीयर इज सिमेट्रिक बॉडी, इस केस में इस ds का n कैप कैसे होगा? बिल्कुल r कैप के तरफ होगा, और यू कैन से इलेक्ट्रिक फील्ड के पैरेलल होगा. व्हाट इज थीटा हियर नाउ? 0 degrees. So see, again using that formula flux, E dot n cap ds, mod of E, mod of n, ds cos theta, q upon 4 pi epsilon, or mod of r, mod of n, ds. What is cos theta here? Theta here is 0 degrees. So what's the answer? Take the constants outside. Q, 4 pi epsilon naught को बाहर निकालने. Integral, surface integral. ds. Oh, cos theta की वैल्यू कितनी होती है? It is equals to 1. तो सिर्फ ds रह गया, और इसे इंटीग्रेट कर लें. It's q upon 4 pi epsilon naught. अगर एक ds है, if it is ds, अगर आप इसे इंटीग्रेट करेंगे तो हमें क्या मिलेगा? स्फीयर का सरफेस एरिया. स्फीयर का सरफेस एरिया क्या होता है? 4 pi r square. तो we'll write it here 4 pi r square. इंटीग्रेट कुछ नहीं करना, आपने सिर्फ समझना है कि ये ds है, ये इस सरफेस का एक सरफेस एलिमेंट है, छोटा सा पार्ट. अगर हम इस पूरे को इंटीग्रेट कर देंगे, we get a whole surface area. And what is surface area of a sphere? It is 4 pi r square. And r is also constant, you can take it out. ds upon r square, you can take r square also out. Why? Because if you take the point here to here or कहीं पे भी surface पे रखेंगे तो distance to r वैसा ही रहेगा, तो you can take r is here constant. So 4 pi r square cancels, 4 pi cancels. What's the answer? It is q upon epsilon naught. So what is electric flux? That is phi e, which is equals to E dot n cap ds equals to q upon epsilon naught. So this is the Gauss's theorem. I am writing it again. What is Gauss's theorem? Flux phi e, which is equals to surface integral of electric field intensity over a closed surface called Gaussian surface, and it equals to charge enclosed divided by epsilon naught, and it is in vacuum. अगर कोई मीडियम होगा, if vacuum is replaced by some medium epsilon r, तो यहां आपने क्या मल्टीप्लाई कर देना है? epsilon r मल्टीप्लाई कर देना है. This is in dielectric medium. एक डायलेक्ट्रिक मीडियम में है, वैक्यूम में क्या है? ये नहीं होगा, सिर्फ एप्सिलॉन नॉट होगा, और डायलेक्ट्रिक मीडियम में एप्सिलॉन आर भी मल्टीप्लाई हो जाएगा. This is the way how to derive Gauss's theorem. You can take irregular surface, but irregular surface needs the concept of solid angle. Spherical surface is very simple. Integrate it. You can take r square, r as a constant, and integral of the surfaces, spherical surfaces, 4 pi r square, and take it, cancel it. You get the same answer, q upon epsilon naught. This is the derivation of Gauss's theorem. Now, one thing more. The charge is inside the Gaussian surface. अगर कोई charge इधर हो, for example q, इधर कोई charge है, for example q2 charge is here, or q3 charge is outside, or some q4 charges out. What is the flux that cuts the given surface? Is called, what is the flux through this surface? The flux remains q upon epsilon naught. It is independent of the charges outside the Gaussian surface. आपको बड़ा अजीब लगेगा, लेकिन ऐसा होता है कि अगर एक Gaussian surface है, इसके अंदर सिर्फ एक ही चार्ज है और बाहर खूब सारे चार्जेस हैं. Flux remains the same, q upon epsilon naught. Charge outside the Gaussian surface doesn't contribute to flux. So that surface. This is the one thing more what I want to say. Got it? That's all for today. Thank you.